This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The next formula we have to prove is that cos A plus B is equal to cos A cos B minus sin A sin B. And the way we do this is to just replace everywhere we see B, we replace it with a minus B in the formula that we proved in the last part. Cos A minus B equals cos A cos B plus sin A sin B. So once we do that, we have our minus B instead of B we write minus B, instead of B we write minus B and minus B. And then what we have to do is use some formulae from our tables that if we have cos of minus B, that's the exact same thing as cos B, and if we have sine of minus B, that's equal to minus of sine B. So the minus comes out in front almost. So if we apply these two rules here and here to what we have up in this equation here, we'll see that this minus B, cos minus B here, just becomes cos B, and this sine of minus B becomes minus sine of B. And inside the bracket here on the left hand side, we have a minus times a minus, which gives us a plus B inside, which is what we want. We're looking for cos of A plus B. So then all we need to do is take the minus out from in here, out in front of this expression, and we can finally write that cos A plus B is cos A cos B minus sin A sin B. Q, E, D. The next proof we have to do is to prove that cos 2A is equal to cos squared A minus sin squared A. And the way we're going to do this is to replace B with A in the equation we just proved in part 5. Cos A plus B is equal to cos A cos B minus sin A sin B. So if we replace every B here, here, and here with an A, we get cos of A plus A, which is just 2A, is equal to cos A times cos A minus sin A times sin A. Now you remember that if we just have x times x, that's x squared. So just the same here, cos A times cos A is just cos squared A. And then once we do that, the equation just drops out. Cos 2A is equal to cos squared A minus sin squared A. And again, we are finished with that proof. Our next proof, number 7, is to prove that sin A plus B is equal to sin A cos B plus cos A sin B. The way we do this is just like the last couple of proofs. We're going to do a replacement, but in this time we're replacing A with 90 minus A in our formula from proof 4, which was cos A minus B is cos A cos B plus sin A sin B. And it'll become clear why we do this in a second. If we do that, we see that this A here, this A here, and this A here are all replaced with 90 minus A down below. And then we're going to make use of two more rules from trigonometry, that cos of 90 minus A is the same as sin A, and sine of 90 minus A is the same as cos A. Now the reason why this is, I can explain over here. If we have a right angle triangle, and this angle here is A, and this is length 1, then we already know that this length over here is going to be sine A, and this length here will be cos A. But if we look at this triangle, we know two of the angles already, and we know that triangles must add up to 180 degrees. So that means this angle here must be 180 degrees minus 90 degrees, our right angle, plus our A. 180 degrees minus 90 degrees minus A, 90 minus A. So this angle all the way up here is 90 minus A. So now if we look at that triangle again, we have a triangle with angle A and 90 minus A. We have a length of 1. We know that we have a length of 1 there, then this side here will be sine A, and this will be cosine A. But if we were to turn this triangle around and look at it instead from this angle, our opposite in this case is this side, so that would actually be sine of 90 minus A. And our adjacent now would be this side over here, so that would be equal to cos of 90 minus A. And that's where those two properties we have over here come from. So this here and here. So once we know that, we can just replace our cosine of 90 minus A from here and replace it with a sine A down here. Likewise, our sine of 90 minus A from here changes into a cosine A here. Then we just have that in this bracket up here, if we take out a minus from these two terms here, then we'll be left with a 90 minus A plus B here. Then, and this is the last trick we have to remember, we have to use the same rule that we had before and say that cosine of 90 minus some angle, in this case the angle we're talking about is the A plus B we have inside, cosine of 90 minus this A plus B. So that's like our angle that we had above, like our A is now an A plus B. So instead of it being just sine A, it's now going to be equal to sine A plus B. So our left-hand side becomes sine A plus B, and our right-hand side is as we have here, sine A cos B plus cos A sine B, and that's the end of that proof.